If I were asked to describe Philips today, I could say simply that it is a diversified electronics company employing people in all parts of the world. That would be a simple statement of fact. Yet it would not really define the considerable strengths of our company. Since the foundation of Philips, three main policies have been consistently followed. The establishment of a firm, healthy base for our activities. A policy of innovation, illustrating by the fact that around 7% of our turnover is spent on research and development. And a policy of diversification within the scope of our company. Today, those three policies are still very important, but now on an enlarged scale, on a global scale. For the company is truly a multinational, and markets outside Europe, for Europe is traditionally the home market of Philips, are playing an increasing role in our activities. Some people have accused me of optimism. They wonder how I can maintain that Philips shall not only retain its present position, but shall also improve and strengthen it in the future. They talk about the poor state of the economy, of the increasing competition in the electronics industry. I truly believe that Philips have all the qualities needed to improve even further its position as one of the world's leading electronics companies. Over the years, Philips have gathered a considerable amount of expertise, which has resulted in a vast number of products. But now, Philips no longer simply use that expertise to develop new products. They use it as a product in itself. Insiders state that Philips are the only European electronics company capable of competing successfully worldwide. They also state that the accumulated expertise within the company is more than sufficient to guarantee its present leading position in the highly specialized field of turnkey projects. I second that opinion, and I'm basing my belief on successes throughout the world, even successes in the very back garden of our major competitors. Philips would never have been able to achieve this position without the knowledge and skills of its employees and the willingness of the customers to buy Philips products. To give examples of all such successes in all the many diversified areas in which our company operates would require more than just a film. And that is why whatever we present can be little more than an arbitrary selection from a very extensive list. You see, Philips today are no longer just a Dutch company, nor even a European company. Philips are truly a world company, with markets in every single continent. Markets not only for products, but most importantly for expertise. Because Philips today means expertise worldwide.
Hong Kong, 1972. The longest submerged tube tunnel in the world is opened under the harbour. Philips have supplied and installed the electrical and mechanical equipment, the lighting, the ventilation system, and the traffic control and toll system. Projections were for a daily capacity of 80,000 cars by the year 2000. Daily capacity now is in excess of 120,000. Taiwan, 1982. The Kaohsiung Harbor Development Project. A newly constructed offshore container terminal, the largest in the Far East, and a tunnel to link it to the island of Taiwan. Philips are awarded the contract for all the mechanical and electrical installations in this tunnel. The competitors? 3 major Japanese companies. The deciding factor? 10 years of absolute reliability in Hong Kong. Successes? Perhaps. Yet little more than illustrations of Philips' expertise in so many areas. Expertise, for example, in electric shavers, a seemingly insignificant consumer product, yet one demanding a highly sophisticated, highly complex production process. Such processes can be found throughout Philips, and each is yet again an indication of the care they give to every product, regardless of its size. Philips have 4 factories where they produce their electric shavers, and the Dutch factory alone produces more than 6 million shavers each year. Undoubtedly, Philips are the world leaders in electric shaving, a position which has resulted from the readiness to invest many millions in both continuing research and state-of-the-art manufacturing processes. One of the latest results of Philips' research is the double-bladed shaving head, incorporating a unique lifting front blade. Independent tests have shown that this Philips system really does shave closer. But even advanced manufacturing processes are of little use without solid research backup. Philips, for example, have devoted considerable attention to research into the ethnic differences in beard growth, with the result that the shaver can be found throughout the world, even in a country with a highly developed home electronics industry, such as Japan. Philips coffee makers, another success in Japan. Coffee has but a short history there. Nevertheless, the Japanese are not only drinking more coffee each year, the majority are making it in Philips coffee makers. Effective marketing depends largely on cost-effective production. And that today means automation, even in areas where manual labor is traditionally inexpensive. In the Far East, for example, Philips are introducing automation into the production of television sets. The semi-automated production line in Singapore is but one of the considerable number of Philips production centers throughout the world, which together produce more than 8 million television sets per year. A different sort of automation, the production of plastic parts for video cassettes. Insignificant? Hardly, since the performance of the Philips video recording system depends to a large degree on the quality of the cassettes. And automation applied here has ensured the required degree of quality by reducing rejects to an absolute minimum. The quality of the cassette is also matched by the quality of the tape. Certainly Philips, the inventors of the audio cassette, have more than enough experience in the field of cassette production. And now they have entered into a joint venture with one of the world's leading videotape producers, DuPont. The resulting joint expertise is more than enough to guarantee absolute quality. Vienna, and a newly constructed Philips factory, specially designed to handle the manufacture of their video recorders. Philips are, of course, the only non-Japanese company to have introduced their own video recording system. Not only in a standard design, but also in a newly introduced portable version. The factory in Vienna is also significant as an example of automated transport applications. This computer-controlled system forms the very heart of the factory. Although such techniques are of value in today's industry, they should never be an end in themselves. They are an aid to improved production logistics. Because Philips realize that a successful company is one that sells its products, not one that uses computers to store products in a warehouse. Electronics is at the heart of so many of today's industrial developments. Traditionally, the center of the integrated circuits industry is near San Francisco, in what is now nicknamed Silicon Valley. Philips too are there with Signetics, which specialize in digital-based techniques. For analog techniques, Philips have center production in Nijmegen, Holland, where the introduction of 4-inch wafers has proved revolutionary throughout the industry. The production process is long, 60 hours required for each wafer, with controls and checks built in at every stage. The complicated equipment required for this is largely produced by Philips' own Scientific and Industrial Equipment division. Undoubtedly, the microprocessor, so often called a chip, is one of the major developments of the last few years. The ability to reduce complicated circuitry and memory banks to literally microscopic sizes has revolutionized a whole range of products and applications. Each wafer carries a large number of individual chips, and these are, in later stages of the process, split and finished separately. Electronics, now at the service of the medical profession. The latest example of ongoing Philips research is a diagnostic technique, now under evaluation with a prototype, called spin imaging. Spin imaging is based on two basic biological facts: that the protons in the hydrogen in our bodies spin all the time, and that additional water is introduced into affected areas as part of the normal healing process. A magnetic field aims the spinning protons in one direction, tunes them as it were, and a short radio pulse makes them vibrate. The resulting resonance is amplified and turned into visual images. Spin imaging is a complete alternative to X-ray, but with no side effects. But Philips believe that their responsibility goes further than just producing equipment. This is why they offer a full medical consultancy service. Fine examples of what can then be achieved can be found in Brazil, Egypt, Greece, or here in Yugoslavia, in the newly built Military Academy Hospital in Belgrade. In Belgrade, Philips offered full consultancy advice on diagnostic equipment for handling emergencies. They also installed therapeutic equipment for complicated radiation treatment and gave advice on how to arrange the treatment areas so that patient stress could be kept to a minimum. Further Philips involvement included the installation of a heart catheterization diagnostic system. Philips also installed full-scale lecturing and teaching facilities and offered complete consultancy on the building itself. Philips involved in architectural consultancy? Of course. In the last 30 years, Philips have built nearly 15 million square meters of office and factory buildings just for themselves, many in the concern headquarters in Eindhoven. Lighting, perhaps more than anything else, is the recognized Philips speciality. Examples abound, each demonstrating the deep understanding of the intrinsic character of each object. The Grand Hotel in Taiwan, illuminated both inside and out, a magnificent example of modern Chinese style. Gothic splendor of the British Houses of Parliament, indeed much of the Thames embankment. The monumental grandeur of Taipei's extensive new memorial and cultural complex. The Rococo charm of the town hall and square in Brussels. But today, lighting poses new demands. As energy becomes increasingly scarce, Philips' response has included the development of the SL lamp, a super energy-conscious means of illumination. The SL lamp makes use of the fluorescent tube technique, but adapted to conventional light bulb fittings. It may seem a simple solution, yet the SL lamp uses only a quarter of the energy consumed by a conventional incandescent lamp, offering the same light output. And what's more, it burns 5 times longer. The SL lamp itself has already been applied in major lighting projects, including the City Hall in Brussels, where the modern lighting techniques complement very successfully the classical architectural style. Another source of light, the intense beam of the laser. Few inventions can have the multitude of applications which the laser possesses, and Philips, already one of the experts in the industrial application of laser technology, are exploiting these uses to the full. Already they are applying the surgical precision of the laser to the manufacturing of the recording heads for their V2000 video recording system. The The laser also plays an important role in a new form of telecommunications, glass fiber optical transmission. In the complicated glass fiber production process, a glass tube is heated and injected with gas, which form precise layers on the inside of the tube. The tube is then collapsed into a solid rod. Each rod produces more than 6 kilometers of glass fiber, about 1/10 of a millimeter in diameter. In the optical transmission system, a laser transmits digital computer information along this fiber, a sort of Morse code, and is turned on and off 140 million times each second. The translucency of the glass fiber is so exceptional that an amplifier is only required after something like 20 kilometers, instead of every 4 to 5 kilometers needed now. Up to 2,000 telephone calls can be transmitted simultaneously. In traditional systems, 4,000 copper wires would be required for this, all of which can be replaced by one single glass fiber. And while this technique may seem advanced, experiments are taking place into increasing capacity even further. Multi-wavelength transmissions will enable about 10 different signals to be transmitted simultaneously along one glass fiber. The various laser light sources, each with its own wavelength, are blended into one stream of information for transmission. At the point of reception, the various wavelengths are once again separated from each other by means of what is called a grating. This technique is particularly promising for use in subscriber networks, since one single glass fiber will carry information for a complete range of communication and entertainment possibilities.
Daarna komt meneer Steenbergen even langzaam afscheid van moeten nemen, want hij gaat de klap verlaten.
الو السيد نبيل، العلاقات العامة بالهاتف السعودي معاك.
يا مرحبا.
لو سمحت ارسلنا لك تعميد بخصوص الضيوف اللي جايين الوزارة الليلة. لو سمحت ترتب لي الأجنحة والغرف المطلوبة، وبنفس الوقت ترسل سيارتين للمطار يستقبلوا الضيوف مع مندوب الوزارة.
The Kingdom of Saudi Arabia, one of the fastest developing countries in the world, and Philips, in a joint venture with Ericsson, were awarded the contract for providing a full-scale telephone network for the kingdom. The telephone network includes traditional switching and transmission equipment, but also makes use of the newly developed Philips optical transmission system.
وعليكم السلام، صالح من سنترال ربع.
سعود معاك من سنترال مدرس. لو سمحت ممكن أسأل سؤال؟
تفضل، ايش السؤال اللي عندك؟
السؤال إنه فينا نحول البي سي ام كيبل لأوبتيكال فايبر كيبل؟
يوم
All in all, more than 1 million individual subscriber lines have been laid to all parts of the kingdom. The project is the largest of its kind to be found anywhere in the world. An interesting ancillary project is the construction of a roadside emergency call system.
الو يا بوليس النجدة. الو يا بوليس النجدة. أنا على بعد 500 كيلومتر من البلد. أنا في الصحراء وأرجو المساعدة.
المساعدة رح تجيك، انتظر.
شكرا.
Traffic control, whether for roads, airways, or navigational waters, is another recognized Philips speciality. Mexico City, one of the largest conurbations in Latin America, with something like 14 million inhabitants and 2.5 million cars to handle daily. Philips designed and installed a complete computer-controlled traffic system based on a number of interdependent levels. The first level involved 750 computers for controlling major intersections. The second level consisted of a number of local computers, coordinating the traffic flow between adjacent intersections. The third level was a number of area computers. And finally, a central computer controlled the whole system. This design means that should there be a malfunction in any part of the system, the whole city will not be affected, but only one small part. And the result? The traffic flow along the main thoroughfares has been tripled, and the initial high air pollution has been decreased to a third. Thanks to this success, Philips are now installing a traffic control system in Saudi Arabia's Yanbu.
Ladies and gentlemen, shortly we shall be landing in Singapore Changi Airport. Please return to your seat. Put your seat upright. Place your tray table to its original stored position and fasten your seatbelt.
Or take Singapore. Holland Signal, a full Philips Dutch-based subsidiary, designed and installed a computer-controlled radar and air traffic control system for the newly opened Changi Airport. The system allows the autopilot of any aircraft using the extremely busy Singapore air corridors to lock on to a computer-generated flight plan.
Please extinguish your cigarette and refrain from smoking until the terminal building.
Okay, got it, thanks.
Garuda 964, expedite taxi.
964.
Delta Delta 299, continue taxi via North Cross 1.
Roger, North Cross 1, holding point, to the right.
Singapore 111, first left, contact ground 121.65.
Roger, first left and contacting ground on 121.65. Good day.
LaserVision, the sophisticated video LP system developed by Philips. A laser beam reading the digital information enclosed in a multi-layered disc. This system is far ahead of the rather conventional techniques developed by competitors in the United States and Japan. Although it was generally assumed that LaserVision would be exclusively a consumer product, it now seems certain it will also make a considerable impact on the professional sector. For example, in reference, education, training, and so on. And LaserVision will also find a place in the Philips Megadoc system for information storage and archiving. A document is first scanned by a laser and displayed on a screen. A code is then added, and both the document and the code are fed into a computer. The information is then transferred to a glass disc using the laser-based process of digital optical recording. Any letter or document can be summoned up on a visual display within 7 seconds, and each glass disc can hold up to 25,000 A4 letters. Or, if the information is transferred directly from a word processing floppy disk, up to 1.25 million pages.
Finansiella terminaler, Karin.
Hej, Stig här. Våra samtal.
Ja, Mr. Wilson från banken i
Sweden, the spearhead for another telecommunications project, Teletex, an interactive communication system between word processing terminals and with telex subscribers throughout the world. An international standards group formed by the world's telephone companies have piloted this project. It was awarded to Philips, thanks to their strong telecommunications background, the word processing experience from their Canadian-based affiliate, and the extensive computer know-how within the company. Digital optical recording, but also digital sound recording, the major step towards the absolute in sound reproduction, brought to perfection in Philips' compact disc system. Measuring just 12 centimeters in diameter, the compact disc, which can contain up to 60 minutes of uninterrupted music, employs digital recording techniques. A laser beam reads a chain of digital pulses called yes-no pulses, which give either sound or silence. Many companies had been working on this, but it was the Philips system which was chosen as the worldwide industry norm. Nor is this an isolated success. Developments are taking place with 4 Japanese companies into a video camera with an integrated, small-scale cassette. This does not happen for sentimental reasons. It happens because the Japanese believe that it is to their benefit to have the expertise of Philips with them rather than against them. Because that expertise confronts them more and more. In Taiwan, for example, where an enormous cultural center is under construction, Philips had already been involved in illuminating the enormous memorial. Now, thanks to proven expertise in a major turnkey project in the Frankfurt Opera House, they have been awarded the contract for providing lighting, electromechanical and acoustical equipment for the projected concert hall and opera house in Taipei. Or must we look to Hong Kong, to the extensive consultancy and participation in the highest office building in that city, indeed in Southeast Asia, the Hopewell Center? Or must we simply look around us, to the many Philips successes not included here? Successes such as the Lagos Ring Road, the extensive navigation systems on the Westerschelde, Bahia State Hospital in Brazil, the Quito Tunnel in Ecuador, or the Top Center building in Sao Paulo. For whether near or far, in whatever continent, whether with mass-produced consumer articles or tailor-made turnkey projects, there are more than enough examples of Philips' expertise. For you see, Philips really do offer expertise worldwide.